Where's my thing? So today, I have the screen froze. We are going to talk about some more equations, obviously, because that's what this whole unit is about, is equations, and eventually we'll get into inequalities. But today we're going to talk about equations where something weird happens, all right? So you don't know something weird is going to happen until you start working it, all right? So some of you might have already started working this equation, and that's fine. So how are we going to work this equation to potentially solve for x? Distributive property comes first. Very good. So what is negative 4 times 2x? Negative 8x. What's negative 4 times 1? Equals, and I'm going to copy the rest because there was no distributive property over there. All right, so now I got an x on both sides of the equation, so I want to get those together. So how do we get the x's together? Add 8x to both sides. And what happens? They make 0 on both sides, right? So since they make 0 on both sides, my variables are canceling each other out. So we don't really have an equation anymore. We don't have any variables to solve for, right? So we're left with negative 4 equals negative 2. Now those are two numbers, right? Are those numbers the same number? No. Does negative 4 equal negative 2? No. So I'm going to put a slash through the equal sign because I can't stand something not saying equals when it's not. And we're going to say no solution. One cool thing about this is the problems are usually shorter to work because once your variables cancel out, you're done. But you have to write down what number equals the other number. All right? And if the numbers are different, you say no solution. Now, sometimes the variables will cancel out and the numbers will be the same, and then it wouldn't be no solution. Okay? But if the numbers are totally different numbers, you're going to say no solution. Okay? All right, let's do problem B. Yes, ask it. Yeah, they're still different numbers. Yes. All right, look at B. Negative 5 minus 9x equals 3 times 1 minus 3x and then minus 8. So what do we do first to solve for x? Distribute. So I'm going to copy the rest of it. And then you distribute. What's 3 times 1? What's 3 times negative 3x? Negative 9x, and then copy your minus 8. Now what do you think we need to do? Yeah, the right-hand side has like terms. What's 3 minus 8? So negative 5 minus 9x equals negative 5 minus 9x. And it don't matter what order you write that. Now we want to get our x's together. How do we do that? Add 9x. And what happens? My x's cancel. And what am I left with? Negative 5 equals negative 5. Is that true? Yeah. That is true. So there are not no solutions. There are infinitely, if I can spell infinitely, many solutions. Now, what does infinitely mean? So many you can't count, right? Right? So the number of solutions that we have to this equation goes on and on forever. So what that means is it don't matter what number is in for x. It'll always be true. There's not just one solution. Every number is a solution. Okay? Every number is a solution. So another way you might see this is all real numbers. All real numbers. I will accept either answer. Okay? Yes, I want you to write it out. No, I want you to make sure you can spell those words. Jeez. It don't matter. Y'all are honors. Y'all shouldn't be whining about spelling something. Yeah. All right. So, here's the thing about this, y'all. You're not going to know when one of these special cases is going to happen. You're just going to be solving equations. Equations, equations, equations. Like tomorrow on your quiz. You're going to have all your equations just lumped together on one piece of paper. All right? So you just work it, work it, work it. So this is just a special thing that, poof, it just happens. All right? It's not going to say, this is going to be a no solution. All right? It's not like a red flag above the problem, whatever. It's just a regular old equation. Okay, so it's just a phenomenon in algebra that happens. So you got to know when your variables cancel out, if the numbers are different, you write no solution. If the variables cancel out and the numbers are the same, you can say if many solutions are all real numbers. But what happens if the variables don't cancel out? It's just like what we've been doing all week, right? You get the variable equals one number, right? So there's only one solution. So normally, the majority of the time when we solve an equation, we get one solution, right? Variable equals one number, right? So that's what's mostly going to happen. But if the variables cancel out, it'll either be no solution or infinitely many. Does that make sense? Make sense? Okay, so I think we got some practice problems. Oh, yeah. 3 of them. So work all 3, see what you get. And you work it like it's possible to get a solution. Because on one of these you may, or all 3 of them you may. And you can't tell me there's no solution without showing your work. If you say no solution and you didn't even try to solve the equation, then I'm going to be like, and no credit. No work, no credit. That's my motto. That's a 2 down there. It just looks stupid. Still looks stupid. You get stuck, let me know. Make sure you copy it correctly. You should not have moved that 3 to the other side without combining my terms. Oh, let's combine my Combine your like terms before you cross these. I'm talking to him either. All right, there's quite a few that are finished. So if you're finished, check over your answers with the neighbor. If you're not finished, you better keep on working. Wait, don't call anybody dumb in here. Y'all are smart. Potentially. Okay, let me just say, y'all. Some of you need to brush up on your multiplication table. This ain't the first time we've solved equations before in our lives either, is it? No. When did y'all start solving equations? Exactly. Well, first grade, but you've done it in 6th and 7th grade too, right? Yeah. And then plus I've already taught you, so we should be a little bit more confident and quicker and more efficient and better at it by now. Right? Right? How are we going to get super good at it? Practice. Some of y'all are going to have to practice a lot between tonight and tomorrow's quiz. All right, so number 1. Like I said, you treat every equation like it has a solution. Okay? Always treat every equation like it has a regular solution. So you just work it. We see distributive property on number 1, so that's what we need to do first, right? So y'all tell me out loud, what's 3 times 2x? 6x. 3 people answered me. Thank you very much. What's 3 times 2? 2. Thank you. And then I'm copying the rest. Now what do? Y'all, before you start doing anything, adding and subtracting on both sides, you've got to combine your like terms. Always. Didn't I go over that yesterday? I thought so. What is 6x minus 3x? 3x plus 6 equals 6 plus 3x. Now we want to get our x's together. And y'all, the reason we want to get our x's together every single time before we start subtracting 6, like what in the heck would that do for us? All right? Because our x's might cancel out. Right? So that's another reason I've always told you, always get your x's together first. Before you add or subtract any constant, get your variables to the other side. So how do we want to get our x's together? Subtract 3x, and what happens? All my variables cancel, and what am I left with? 6 equals 6. Well, does 6 equal 6? Yes, so we can either say infinitely many solutions, whatever words you choose, or what? All real numbers. You don't have to tell me both. You can tell me either one. So raise your hand if you got infinitely many solutions or all real numbers. If you got no solution, that is wrong because this is true. Okay? Good job. Number 2, we solve it like it's a regular equation. So what do we need to do first on number 2? We got to distribute on both sides, don't we? All right, what's 6 times 2x? What's 6 times negative 6? Negative 36 equals what's negative 7 times negative 2x? 14x, and what's negative 7 times 4? And then we want to get our x's together, right? How do we want to get our x's together, somebody? All right. You could subtract 14x or you could subtract 12x. I'm going to subtract 12x because it's smaller. So I don't know why I put 3x there. So negative 36 equals 2x minus 28. Now what? Add 28 to both sides. What's negative 36 plus 28? Negative 8 equals 2x. Then what? Divide by 2. What's negative 8 divided by 2? Raise your hand if you got negative 4 equals x for your solution for number 2. So how many solutions does this one have? 1. So it was possible to solve this one, right? My variables didn't cancel out. If your variables don't cancel out, it's just like we've done all week. Right? If your variables don't cancel out, it's just a normal one. Don't fault it for being normal, okay? Okay? You just get an answer. All right, number 3. What do we do first on number 3? Distribute. So I'm going to copy that 3x minus 13. And what's 7 times x? What's 7 times 2? And then I distribute over here. What's negative 4 times x? And what's negative 4 times negative 7? Very good. Now what do I need to do? Yeah, all those x's and constants on that side of the equal sign are like terms, so I have to combine those first. So 7x minus 4x is 3x. And then positive 14 plus 28 is what? 42. So I'm having 3x minus 13 equals 3x plus 42. Now what do I do? Subtract 3x, get my variables together, and what happens? All my variables cancel. And I'm left with negative 13 equals, is that true? No. So this is a no solution. Raise your hand if you got no solution for number 3. All right. I will tell you on the quiz tomorrow there will be, I don't know exactly how many, but there will be some of these that pop up in there, and they will be thrown in with the regular ones that do come out to be solutions. So you're talking about like the no solutions and I don't know if there's one of each. I'll have to go back and look. Actually, I can look right now. Heck yeah. There's one of each. There's one of each. Okay. One last thing that we got to learn about, a special kind of equations. Proportions. Proportions. All right, so proportions is another word for saying equivalent. Talk big words. Equivalent ratios. Equivalent, what does equivalent mean? Equal. What is a ratio? It's a fraction. So a proportion is 2 fractions set equal to each other. Basically, that's what a proportion is. 2 fractions that are equal to each other. That's a ratio. Okay? So like 1/2 and 4/8. Those are equal ratios, aren't they? Right? 1/2 and 4/8. So that would be a proportion. Right? Okay. So proportion is just two fractions set equal to each other. Now, you might have seen this before. Problem C is an easy one that you might have seen before. To solve a proportion, you cross multiply. Cross multiply. Have y'all heard of this before? So that means you're going to multiply the diagonals and set those numbers equal to each other. So copy down example C, please. 4/3 equals x/6. Now this is a very simple proportion, but as you see, they're going to get more complicated. Yeah, that's math for you. All right, so to solve example C, I'm going to multiply the diagonals. So one set of diagonals is 3 and x, right? What is 3 times x? And you write it down, 3x. Equals, the other diagonal makes 4 and 6. So what is 4 times 6? 24. And now we have a little baby equation to solve, and then we're finished. Yes? This one you can, because coming up, we're needing to know the original process to do it.
So we can go ahead and do it for
I need to see some work. I need to see some work because it's a process. Because look right here, it gets more complicated. So I'm trying to show you the process right now, not take shortcuts. All right, so now what? Divide by 3. And x equals what? Somebody needs to learn times tables. No. All right. So, and we can check it right here, right? And I think this might be what he was talking about. What times 3 is 6? 2. 4 times 2 is that what we got for the answer? Yeah, and we can also know that this reduces to, well, that is 4/3, so it's an improper fraction. We know this is going to be an improper fraction, right? So we know that our number needs to be on top, bigger than 6. Does that make sense? Yeah. Okay, so we can check our answer like that, absolutely. But the reason we want to do the cross-multiply process is because what if we have a proportion like this? When the variables are in a spot that's not just the variable in there, it has something else with it. So we need to know the process. Okay? Got it? We are. Okay. So let's do that. So on D, write D down if you haven't already. 2/10 equals 4/n plus 5. So if your variable is by itself in a numerator or denominator somewhere in a fraction, that's pretty simple. You just stick that number with it when you multiply, right? 3 times x is 3x. All right? But if you have a plus or a minus with your variable, you're going to have to set it up to distribute. So where my variable is down there, that n plus 5, its diagonal buddy is the 2. So when you multiply 2 times n plus 5, you need to write 2 parentheses n plus 5. Because it's not just 2 times n, it's 2 times that whole denominator down there to n plus 5. If you just do 2 times n and write plus 5 with it, it's going to be wrong. You got to distribute the 2 to all of it. Okay? Equals the other diagonal. What's 10 times 4? 40. So any questions about how we set that up? Any questions about how we set that up? Okay. So now we just solve the equation. First we need to do what? Distribute. What's 2 times n? 2n. What's 2 times 5? 10 equals 40. Now what? Subtract 10 on each side. What's 40 minus 10? So 2n equals 30. And then I do what? And n equals 15. So y'all see what we do there? So if your variable has a plus or a minus with it, then you're going to have to distribute. Okay? That's basically it. So I like to do the one, and it don't matter like which diagonal you put on the left or the right when you solve your equation. I usually like to do my variable first if I have one variable. What's going on over here on E? I got two y's, don't I? So I'm going to have a variable on both sides of the equals on this one. Some of them it works out where you don't. That would be quadratic, so you ain't going to have that. No. Okay. I was thinking too far ahead of you guys. I'm going to stop. So on one side, 5 times y minus 3, what do I have to do there? Distribute. So it's 5 parentheses y minus 3. And I want to see that step, okay? Equals the other diagonal. 2 times y is what? 2y. So any questions about how I cross multiplied and set it up? Okay. So now that I got it set up, what do I do first? Distribute. What's 5 times y? What's 5 times negative 3? Equals 2y. Very good. So what do you think we're going to have to do first now to solve? Not first, we've already done something else. What do you think we have to do next to solve for y? Yeah, and it would be wise to subtract 5y on both sides because that 2y was already by itself. And if you move 2y, you wouldn't have anything left over there. Okay? And it's more work that way, trust me. And then so I have negative 15 equals what's 2y minus 5y? And then how do I solve for y? Divide by negative 3. What's negative 15 divided by negative 3? Y equals positive 5. Very good. Good job. We see how it's going? All right, so F is just a little bit different configuration. So these examples, we're doing the same thing, y'all. They're just moving the variables into different parts of the fraction. Yes, sir. Those are ends. That bottom one looks like a something. I'll fix it. I'll fix it. Is that better? They're ends. They're the same variable. All right, somebody tell me what's going to be on one side of the equal sign. Yeah, 5 parentheses is on one side. And what goes on the other side? So it doesn't matter if this one comes first and this one comes second, as long as you have this on one side and this on the other side. Does that matter? Is that okay? It don't matter, but you know what I'm saying. Okay. So now what do we need to do to solve for n? Yeah, we're going to distribute on both sides. So what's 5 times 2n? 10n. What is 5 times negative 3? Equals, what is 3 times n? And what is 3 times 9? Okay. So far, so good? Now what do we want to do? Subtract 3n to get our n's together. And what is 10n minus 3n? 7n minus 15 equals, and then what? Add 15 to each side. So 7n equals 42. Then what? Divide by 7, and n equals, oops, I'm out of space. That one was kind of long, wasn't it? Well, just because I think I probably skipped it. But this is not terrible. It's not complicated, right? They might take a minute, but they're not complicated. So G is the same thing again. It just has your variables in different places. M minus 4 over 6 equals M minus 7 over 9. Somebody tell me what one side of the equation is going to say when I set it up. 9 parentheses, N minus 4 equals what? Oops. 6 parentheses, M minus 7. Everybody okay with that? And then what do we do? Distribute. What's 9 times M? 9M. What's 9 times negative 4? Equals what, 6 times M? What's 6 times negative 7? Okay? Now what do we want to do? Subtract 6M on both sides. What's 9M minus 6M? 3M minus 36 equals negative 42. Then what? Good. Add 36. So 3m equals negative 6. Then what? Divide by 3, and m equals negative 2. Are there any questions about how to solve proportions? Yes, sir. Yes. Can you do it in your head? I'm going to ask that you show me this step just so tomorrow I'm grading a quiz for you guys, right? Right? Say you missed the problem. You get the answer wrong. Right? I don't like to grade short answer quizzes as, okay, if there's 6 points apiece, count off all 6 points if they got a 2 instead of a negative 2. I like to try to give you partial credit, right? The more work you show that lets me know that you know how to do it, you just might have misadded something, right? The more points I can give you back on that problem. So I would prefer you show me that step, at least until after the quiz tomorrow. Does that make sense? Okay? Because I'm trying to give y'all credit for what you do know, even if you make a simple mistake somewhere. Does that make sense? So it's really in your benefit to be in the habit of showing all your work, even if it's simple like that. All right? Because I try to give you credit for what you do know, even if you might have missed the answer. Does that make sense? Okay? So always show all your work as much as possible. All right. I want y'all to try this one. This will be our last example for today. Bless you. It's just because y'all are quiet working a problem. Like when we're having class, you can't hear it. All right, y'all check your answers with somebody. Yeah. Good try, buddy. All right, y'all look up here, everybody. Okay. Ready? It's a proportion. First of all, like, I don't know. Let me look at your quiz. On your quiz tomorrow, it's not going to say, this is a proportion, cross multiply. I mean, I'm telling you, look, here you go. Here's your quiz. You want to see it? Here it is. This is your quiz. There are 12 equations. That's it. And the directions say, solve each equation, show all work. So it does not say, hello, this comes in a solution. Or, hello, this is a proportion. You got to know it's a proportion. Now, how do we know something's a proportion? When it looks like two fractions that equal to each other. Now, how do you solve every proportion? Cross multiply. Okay? So you got to be able to know that's a proportion I cross multiply. Okay? Okay? I'm telling you, it's all same direction, a front and a back. There is a bonus with a little snail picture on it. I don't know why there's a little snail picture on it, but there's a little snail picture on it. But yeah, 12 questions and a bonus. And that's it. They're all just lumped together. Yes. It's a bonus is an equation. All right. So y'all agree with me that's a proportion, right? So how do we solve proportion? All right. On one side of the equals, somebody tell me what I put on one side of the equals. Okay. I did, didn't I? Okay. 2 parentheses 4x plus 9 equals. All right. So distribute. What's 2 times 4x? What is 2 times 9? Equals 3 times 3x. And 3 times 7. All right. Now what do we need to do? Now you can subtract 8x or you can subtract 9x, right? I'm going to subtract 8x because I like positives. So 18 equals 1x. Now if you put a 1x there, same thing, right? Subtract 21. What is 18 minus 21? That was a dyslexic moment, wasn't it? I have that. So raise your hand if you got -3 for your final solution. Are there any questions? All right, so that is the end of notes for today.